All right. Hello, everybody again. It's Mr. Merrifield once again. We're going to go over another kind of review video. So we're going over kind of the basics of percents, a few example problems, and I'm even going to show you a new kind of non-proportional way to solve these, sort of the more algebraic way. So to start, we'll just go over the basics, and what I recommend, if you don't have to memorize something in math, don't. Be able to logically run it through it because that's all this is. So we're going to start with just our definition of a percent proportion, and everything will build off of that. So let's start with, well, we know what a proportion is. That's just something that's defined as a part out of a whole. And we got our proportion. So now let's look at, well, what does it mean to be a percent proportion? So per is essentially a rate. Cent, we know what that is. If we do like the actual just like disambiguation of that word, we'd find that it's really goes down to out of 100. If you forget that, just remember 100 cents in a dollar. Percent just means a rate out of 100. So our percent proportion just means that we got a part out of a whole, and that is equal to a percent that is a ratio where the whole is out of 100. And so from that, we can build every other one of these. And really the big one is the percent change. Percent change builds markup, markdown, and it builds kind of our percent error and our interest rate formulas. So what we're going to start with, or should I say, what we're going to build on is that percent change proportion. So remember when we had this example of like the building and the goldfish, and they both grew an inch, and if the building grew an inch, to this picture, you might add not even a pixel. I'm probably even exaggerating it there. But the goldfish growing length of an inch, we could have a goldfish that's about twice as big. So we want a better way than just absolute value on how to describe something. So that builds our percent change proportion. So all we do is if we're building a percent change proportion, we can really just start with this proportion and tweak it. So instead of percent, a percent proportion, we're looking for a percent change. So on this top right, we're just going to change that to percent change. And it doesn't matter if it's a percent or a percent change, it's still out of 100. Well, if we look at this, we're looking, instead of a part, we're looking at a part change. And we can just shorthand that down to the change. And one thing that we want to be specific on with what goes here. This is the example that I like to give. So let's say the last time, well, this would be true. The last time I saw you was about, I don't know, a month ago. So way back, beginning of March, let's just estimate that you were this tall. Forgive that your torso is a little skewed there. So this would say last time. And let's say we do our team meeting on Wednesday. You pop up on video chat, you've got a webcam going, and all of a sudden you are this tall. And I'm here, I'm looking at on the video, and I go, oh my gosh, you have grown about 50% taller. And so what we want to ask is, well, am I saying that you're 50% taller from the last time I've seen you? Or am I saying you're 50% taller than now? It'd be kind of strange for me to say you're 50% taller than you are now. I'm referring to the last time. So instead of whole, we got to be a little bit more specific on which whole we're talking about. We're talking about the original or the previous whole. And from there, these are our two big ones. We got our percent proportion if we want to find a part, a whole, or a percent, given the other two. We've got a percent change, where if we want to talk about increase and decrease and talk about it a little bit more specific than just absolute growth. And from here, we can build like some specialties. So your big one's going to be your markup, markdown. So markup, you can just think of that as a price increase. Markdown, that's just going to be a price decrease. So you could think of like a sale and kind of like a, I guess, unsale if they're putting the price up to try to make a profit. So from there, a markup, if it's a percent increase, that's really no different than a change. So really, instead of talking about change and percent change, we just get a little bit more specific. We're talking about markup and percent markup. But it's really no different than using a percent change formula. That'll be over 100. And again, we're talking about the original or the previous price. And you could make this exact same proportion and just do markdown. So if it's sale, this becomes markdown. This becomes percent markdown. And of course, we have those specialty applications. So remember, we had that error. We had the error over the actual. Again, error is kind of like being off by a certain amount, so it's really not that much different than a change. We're just talking about change more specifically, how far off you are. Actual, what was it supposed to be? And that's going to be able to get you your percent error over 100. And of course, we had one more application we looked at in that unit. We talked about what about an interest rate? So remember, we had the interest, and that is going to be related to an interest rate, which we'll just write as percent interest. And we had that weird word that we talked about where we go, what is the interest acting on? And we gave it kind of a specific word. We gave it the principal, which is kind of like the loan or the investment. So what is the interest acting upon? And of course, it's going to be related to a percent interest out of 100. So we got kind of like our big 5 proportions, but really you only need to know how to find this. And from this, we can build all the others. So before we jump into an example of this, I want to show you kind of a new way to do this. So I wanted to show you guys when we did this, the equation unit, but of course that got cut short a little bit. So instead, I'm going to show you it now. So we're going to look at a way to solve it algebraically. So remember that method I showed you where we had something like x, let's say plus 7 equals 30, and you were trying to find the solution. Actually, to make this a little bit more relevant, I'm going to make this a multiplication. Like if we had something like 3x equals 30. And I'm going to make this a little bit more specific. So we'll take the implied, make it explicit. This is really a 3 times x. And remember we had that method of solving algebraically where we could say, oh, well, I'm just going to undo the steps that are happening to x. So here, 3 times x equals 30. Another way of saying that is 3 times some unknown number is equal to 30. Well, you could reason it out logically and say, oh, well, that number must be 10. But we also built that new method that would allow us to solve even more complex problems where we said, oh, well, this left-hand side's being multiplied the unknown value by 3. Let's do the opposite operation. But of course, to balance it out, we have to do it to both sides. And we get x is equal to 10. So I'm going to erase that for a second. But just knowing that, we can take this proportion that we just remembered, and we can make a formula for the part, we can make a formula for the percent, we can make a formula for the whole. So this should be pretty new, but it's just a way to solve the things that you already know how to solve with the proportions, just a little bit more elegantly. So let's start with this right here. Let me erase that arrow so we have some room. So say if we want to get the part, so a formula for the part. So I'm looking at it. I'm going to kind of just section it off. And I'm going to say, well, the part is being divided by the whole. Well, what if we were able to just get part all by itself? So what I'm going to do is I'm going to use that balance method. I'm going to multiply both sides by the whole. So let's look at what's happening on the left-hand side. Well, the part's being divided by the whole, and it's being multiplied by the whole. So those operations cancel each other out. All that's left on the left-hand side is the part is the part. And on the right-hand side, I've got the percent over the 100 divided by the whole. So what we can say from that is essentially, if I want to find the part, that is just equal to the percent over 100. And once I find that, I just multiply it by the whole. If I want to find a part, percent divided by 100, multiply it by the whole. And again, we could substitute this in for part change, percent change, and that original. We could solve any problem we want that involves us finding the part. So let's do the same thing. Let me get my eraser tool real quick. Let's do the same exact thing, but let's find the percent. So the percent's being divided by 100. Let's multiply both sides by 100. So remember, whatever I do to the left-hand side, got to do the right-hand side. 100 multiplied and divided cancels itself out, and I'm just left with a percent. So formula for percent is just equal to, and just to make this a little bit easier, I'm just going to swap the order of multiplication. So let's do part over whole on the left-hand side. Again, don't worry that I'm flipping the equals sign around. I'm allowed to do that as many times as I want. Any statement where the left-hand side equals the right-hand side also means the right-hand side equals the left-hand side. So now I've got a formula for the percent. So if I want to find the percent, I just take the ratio of part over whole, multiply it by 100. Now, this one's a little trickier. So see if you can follow along, but I'm going to derive for the whole now. So this will be a little bit stranger, but bear with me. So I'm going to start with just its shorthand. So part over whole equals to percent over 100. So what I'm going to do first is I'm going to try to get the whole here out of the denominator. So what I'm going to do is I'm going to multiply both sides by the whole. So here, whole divided by whole, or if I think of part, whole and whole, those will divide out. So now what I'm left with is part over 1, which I'll just write as part, is equal to percent over 100 times the whole. And now this is where it gets a little weird. So what I'm going to do is I'm going to try to get the whole by itself. So I'm going to divide off by percent over 100. And remember, I've got to do the same thing on the right-hand side, but I'm going to do it in a different way. Because remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So on the left-hand side, I'm going to do the exact same thing, but I'm going to balance it out by doing the same operation, but just doing it as multiplication instead. So from there, if I want to get the whole of something, I could get the part times 100 divided by the percent, and that's kind of the weird one. So we'll have these in our back pockets now. If I want to find the part, percent of 100 times the whole. If I want the percent, part over whole divided by 100. If I want the whole, part times 100 divided by percent. So now let's look at an example really quick. So I've brought an example where we've got a cell phone being marked up. So we've got this cell phone here, it looks pretty fancy, and we've got the original price is 300, but whoever's selling it is trying to make a profit, and they're selling it for 465. So I always like to ground this in kind of the visual if I can. So let's just start. No, you don't always have to do this, but I want to give this as an example just in case it's useful. So I'm going to start and just draw kind of a bar chart. So we'll do kind of a first bar, and we'll say that bar represents what they bought the cell phone for. So we'll do $300. And then I'm going to come over here, I'm going to grab another bar, and of course we want to make it bigger because they're marking it up. So let's start, and let's maybe draw, it's a good deal bigger. Maybe 465 would be about there. So I'll take this, label it as my 465, and of course this leftover bit here, that is my markup. But we don't want markup, we want percent markup. So if I want the markup, I know that is going to be 465 with the 300 bit here taken away because I'm just looking for this distance, which of course, that will give me, I'll just make this into an equal sign. That'll give me $165. So they took this cell phone, they marked it up by $165. So now, all I have to do is use my percent proportion. So we'll go back to that first slide real quick. And we know that we want to grab this one right here. So we'll take the markup over the original is equal to the percent markup over 100. So let's write that down. And I'm going to write it in shorthand. So we got the markup over the original is equal to the percent markup over 100. Well, I have the markup. I also have the original. So let's plug that into my proportion here. So I've got the markup, it's 165. That'll go in the top left. And I've got the original, that's 300. I know 100 goes down here just based on the definition of a percent proportion. And I don't know this, but that's totally fine, because if I have one unknown in a proportion like this, I can always solve for it. So we'll do this kind of the proportions way first, then I'll show you how to do it with the algebraic way. So let's label this one. This will be the proportions method. So what I'm going to do here is I'm going to look for a common multiplier across. So I could go up and down, but 165 and 300, those look like kind of annoying numbers to work with. However, 100 and 300, I know how those relate. 300 divided by 100, that's 3 times bigger. So I know that there is a multiplier here by 3. And I also know I could multiply 3 that way, but I'm trying to get to my hidden unknown. So instead, what I can do is I can rationalize this as if I can multiply it by 3 here, I can go the other way and divide by 3. So of course I could have worked up and down, but I saw this relationship between 100 and 300 made life easier. So I can say x, which I define as my percent markup, it's going to be equal to 165 divided by 3. And I could break out long division if I want, but we're kind of beyond that at this point. So just pull up my calculator real quick, 165, divide that by 3. Oh, we got 55. So x is equal to 55, which of course tells me this phone was marked up by 50. Go ahead and fix that. 55%. And that will be my percent markup. All right, let's look at this one more way, because of course we have this kind of old school method, but now we're kind of building towards algebra. So I want to show you this new method where we just solved for something algebraically. So what I need is I'm looking for the percent markup. So I'm going to grab this proportion here. Percent is equal to part over whole divided by 100. So we got percent times 100. I think I said divide by 100, but of course I mean multiply 100. So hold up, my screen disappeared for a second. Oh, we're back. Okay. So what I'm going to do here is I'm just going to plug in the values that I know, but I'm going to tweak it first. So percent markup is equal to the markup over the original times 100. So we're just going to tweak that original formula. Part here is the markup, whole is the original, percent is the percent markup. So same way I tweaked my original proportions, I just tweaked this. So here, I've got my markup. It's still 165, same math here. We're just looking for this leftover part, 165. What did the phone originally cost? It was 300. And to finish it off, I'm gonna have to multiply by 100. So let's try that, see if we get back to our original 55%. Does our algebraic method work as well? So pull back my calculator, and we'll do this math really quick. So we got 165, divide that by 300. And then of course we gotta multiply that by 100, and it tells us the percent markup is 55%, and we solved it. So no matter what you're trying to solve, you can use either your proportional method. All you have to do is plug in your two knowns and then solve for your unknown, and you could do it this proportional method or you can do it with this new algebraic method that I showed you. So whichever way you do it, and I would recommend even trying both just to see the relationships, but you should always get back to that same number, and it's a good way to kind of check it. So kind of wraps up our video for this week. So I'll post some practice, probably find some Desmos activities as well, and then I'll also post kind of some more puzzles for the week. So hope you guys are doing okay. This is Mr. Merrifield signing off, and looking forward to chatting with you guys on Teams real soon. So take care. Goodbye.